Okay, let's do a 2D problem, but this time areas instead of lines. If you look at that shape, there's obviously three areas. You could do it like this, the small square, this big rectangle, and this triangle. You could do it like this rectangle like that, this little stacked square there, and this triangle. But no, what we're going to do instead, to be different, we're going to take this giant square and this giant triangle, and then we're going to subtract out this little rectangle. And this is pretty cool. We're going to demonstrate how to subtract stuff out. This will be useful if you ever need to find the centroid of an area that has a hole in it. Sometimes you'll have a beam like this, and you have a pipe going through there, and so that's actually a hole, and you need to find the centroid of something like that. But anyway, this is the one we're going to do. We're going to do the triangle, the big square, and then a negative little rectangle that we're going to subtract out. And we'll learn how to handle the subtracting out in this example. So here we go. This big square there is 3 feet by 3 feet, so the area is 9 feet squared. And that is just a 3 feet by 3 feet triangle, so half of that, so that'll be 4.5 feet squared. The centroid of this 3 by 3 rectangle is at 1.5 feet negative x and 1.5 feet positive y. And the centroid of the triangle is a third of both dimensions, so 1 feet positive x and 1 foot, positive y. Then we have the rectangle we need to subtract out. It's 2 feet by 1 foot, and it has an area of 2 feet squared. And the centroid of that is shown here. It's 2.5 feet over because it's 2 feet to this edge here is 2 feet, and another half a foot to the center, and it's 2 feet from the bottom. Okay, I am not going to call these shapes names like Sasquatch and whatever, but I still think just 1, 2, and 3 is not very clear, so I'm going to actually just sketch that. That's going to be the triangle, that's going to be the big square, and number 3 is the small rectangle that we're subtracting out. The triangle we got earlier had an area of 4.5 feet squared and 1 foot and 1 foot for x and y bar. The square we got was 9 feet squared, and again, these were the coordinates to that. And here is the area of the rectangle. So what's very important here is that this has a negative area because we're subtracting it out. And then we just put in the x and y coordinates, and you use the same Excel spreadsheet that you made earlier. Just change the numbers, and this will give you x times a, y times a, x times a, y times a for all the pieces, and it will automatically add them all up, including the minus signs. And then if you take sum xa over sum a, you get that for x bar, sum ya over sum a, and you get that for y bar.